So we have looked at two sample hypothesis. If you can remember, that was the independent t-test, which we looked at here. Then we looked at the Mann-Whitney U-test. We've done it all by hand computation. Sorry, the independent t-test, we looked at the paired t-test, And then we looked at the Mann-Whitney U-test, which is an independent test for non-parametric. So we did that. Today, if time permits, we'll look at the R version of that, how to do all of that in R. And then what we are going to do today is ANOVA, which is right here, analysis of variance. And we shall also do the R version of that. So today we are going to do the R version of the paired, the Mann-Whitney, and the ANOVA. We shall use the Brukutu data set, the data set that you already have, which you know, and all the commands that you have already typed. All right, so let's get the ball rolling. We are going to today, first thing we are going to do is we are going to look at analysis of variance. And we are going to follow the same steps in hypothesis testing. You see, all this while we have been looking at two sample. And what we are going to do is more samples, 3 sample, 4 sample, 5 sample. But in order to make things simple, I will just be doing the, the 3 sample with you. Because the same approach is what you will use to do the 4 sample, 5 sample, 6 sample, or multiple samples. So in order to do that, I'm coming to give you a certain data set so that we can play with that data set. Okay. The data set is given by the following. These are the salaries in thousands of Ghana cedis across 3 different MBA groups. The salaries are in thousands of Ghana cedis across the 3 different MBA groups. The RMBA, the regular MBA, they earn 1,000, 2,000, 3,000. The weekend MBA earn 4,000, 5,000, 6,000. The EMBA earn 7,000, 8,000, 9,000. So this sample is obviously 3 samples. So what we want to do is to determine whether a statistically significant difference exists across the mean salaries of these 3 MBA groups. We know, we can see with our naked eye that the EMBA seem to be earning more compared to the WMBA, who also seem to be earning more than the RMBA. But the question is that, is the difference statistically enough to warrant a rejection of the null hypothesis? Can we subject that to statistical fire? So the null hypothesis is actually saying that there is no difference in the mean salaries. How would you write a null hypothesis? Well, you write a null hypothesis like this. You always bring each note. You see, there's a standard on how to write a null hypothesis. The null is HO, the alternative is HA. Now you can see that this time, for the first time, I'm not saying you should write something first and then come and detect which one is a null and which one is alternative. No. Rather, you write the HO first because you know you're going to write it now. And we are dealing with the means, So you just write mu1 is not equal to, is equal to mu2, and mu2 is equal to mu3. Now, why am I doing 3? Why didn't I do 4? Because our sample we have here is made up of 3 categories, 3 groups. And so that is why I'm doing 3 means. How will you write the alternative? You just write that mu I is not equal to mu j for at least, please write what I'm writing, 1I for at least 1I, comma j equal to 1 to 3. For at least 1I for j equal to 1 to 3. So the null hypothesis is saying that there is no difference in their means. The differences are the same. The alternative is saying that hang on. Probably at least one of the means is different from the other. And you don't need all the means to be not equal to the other. You just need only one of them at least to be not equal to the other, and that will nullify, destroy the null hypothesis. So the null hypothesis is saying that there is no difference. The alternative hypothesis is saying that there is a difference. How do we do the analysis? We just have to subject everything to statistical torture, and then we'll come out with a conclusion. So this is the first step we use to formulate the null hypothesis. But let me ask somebody here. In order for me to understand, you understand what I've just understandably, taught you. I want somebody to tell me, how will you formulate the null and the alternative hypothesis if the groups were 5? If the groups were 5, how would you formulate the null and the alternative hypothesis? Who will answer that for us? Who would try? How would you formulate the null and alternative hypothesis if the groups were 5? You don't need to make some significant change. All you got to do is to just realize that this time we don't have 3 groups, but we have 5 groups. How would you now do it? Eric, wait, Agnes or something.
Okay, so I want to try for the null.
Well, you have to try for everything. Don't worry, you can do it.
Okay, so new 1 equals new 2 equals new 3 equals new 4 equals new 5.
Perfect.
And then for alternative, new I is not equal to new j, and it's not equal to new k, and it's not equal to new l for at least one
Okay.
for at least
I mean, you already had the intention of not doing the second one, and I think it's so let's let someone guide you. Eric, ignore the first one because she's already done the first one, and that was correct. Let's deal with the alternative.
So the alternative hypothesis.
Eric, check your microphone.
Is it okay now?
Yeah, better.
Thank you. So the alternative hypothesis, new 1.
Oh, Eric, you've gone back again.
Hello, Doc. Please wait. Okay, sorry. So with our alternative hypothesis, mu I is not equal to mu j for at least 1 mu j, that's ij, and it's equal to 1 minus 5.
1 minus 5 by what?
Then
it's 1 to 5.
1 to 5, sorry.
Very good. So ladies and gentlemen, all you have to do is to just, for the alternative, you don't do anything. You just change the number of groups from 1 to 5. That's all. That's all. That's how you formulate. So it doesn't matter how many groups there are, you can still formulate a null and alternative hypothesis. Okay. Now let's go to step 2. Step 2 of hypothesis testing. Who can remind us of step 2 of hypothesis testing? What is a step 2? Whenever you're doing hypothesis testing, step 2. Ajua.
So you find the test statistics and the critical value.
Very good. And that's what we are going to do here. We're going to find the test statistics and the critical value. So how do you do that? Well, because this is ANOVA test, analysis of variance. ANOVA means analysis of variance. The variance means difference. So you need to create a table which is known as the difference table. And this is how you create a table. You create something called the source of variation. Do it along with me. Then you create the means, create the source of variation, the sum of squares, the degrees of freedom, the mean square, and finally the F statistic we are looking for. All right. Now, under the source of variation, there are two sources of variation. One is the between group variation, and then the within group variation. You see, if you look at the values, look at them one by one, you will notice that as you look at the RMBA versus W for this, the E, you will notice that there are differences between the groups, are there not? There are differences between the groups. And when you take one group alone, there are also differences within that group. There are differences within that group. So obviously, analysis of variance is trying to look at all of the potential differences and come out with a statistic. And that is what we are going to do. So the first row is going to examine the differences between the group. Then the second row will look at the differences within the group. Okay, so how do you find the first one? Now let me take you back to something in your slide you already know. I'm just jumping. You will see a table here. Okay, the table that you can see here, let me just, and please, you want to draw it. You want to draw what I've just drawn on the screen. Let me just, the table that you have here is just exactly the one I spoke about. The between group differences and then the within group differences. So what we are going to do is to first of all find this SSJ. SSJ, what is that? That means that it is a certain formula you got to know. The formula says that SSJ is equal to the sum of Ni, the sum of Ni, brackets Xi bar minus X bar or square. Please write it down. Please write it down. Summation of Ni, Xi bar minus X bar or square. X bar or square. So what is Ni? You can tell me. What is Ni? If you know, you can tell me. Ni basically stands for the sample size in each group. The sample size in each group. So if you can remember the data set, you had 1, 2, 3 for the group 1, 4, 5, 6 for the group 2, 7, 8, 9 for the group 3. So it means that the sample size in each group in this very example is 3, 3, 3. So we have the groups as RMBA, WMBA, and then EMBA. And each one has 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So the first thing you're going to do is to identify that each one of them in this case is 3. The next thing is the information you have here. The Xi bar. The Xi bar is standing for the mean in each group. So if you look at the RMBA, what is a mean in that group? If you look at the WMBA, what is a mean in that group. If you look at the EMBA, what is the mean in that group? As you find the mean, so we are actually going to find the X1 bar, then we find the X2 bar, then we find the, let me just, okay. Then we find the X3 bar. But the last part of the formula right here means that we also need to find the X bar bar. The X bar bar is the grand mean. It is a mean of all the observations. It is the overall mean. That is the X bar bar. Ladies and gentlemen, who can tell me the X1 bar? Raise your hand and tell me. If you have honestly calculated by yourself without checking anywhere, what is the value of the X1 bar? Valentina.
2.
Very good. The X2 bar, who can tell me? By the way, I'm already giving marks today, so I don't have to tell you I'm giving marks before you talk. Just note. Agnes. Or Agnes wasn't. Marian.
5.
5, sir.
Okay. And then the X3 bar. Unique. Favor.
Say
8.
Okay. So you notice that you have 2, 5, 8. Okay. So those are the values for the means. Those are the values, 2, 5, and then 8. Now, what is the X bar bar then? What is the X bar bar? And I'm not interested in the answer. I'm going to ask you how you calculated it. What is the X bar bar? The X bar bar. What is the value of the X bar bar? Let me go to Valentina.
3.
Okay, that's not correct. What is the X bar bar? Ali.
5.
Ali, how did you get it?
I added all the X1, X2, X3 and found the mean. So 15 divided by 3 will give me 5.
That approach would be wrong. Yeah, very wrong, actually. Even though the answer is correct, the approach is wrong. And I'll tell you that very soon, because you are not calculating, you are not finding the mean of means. You are finding the grand mean. Innocent, how do you calculate it?
Okay, so Prof, I added the individual values, 12, 1, 2, 3 up to 9 and divided by 9.
What did you get when you added 1, 2, 3 up to 9?
Let me go back to it. I had 45.
Okay, good. So, and I'm coming back to my good friend. When you add 1, 2, 3, 4, 5, all the way up to 9, you get 45. 45 divided by 9 will give you 5. The fact that this is 5, the same as the other one is 5, doesn't make the other one correct. The reason why the other one happens to be equal to this was because the sample size was 3, 3, 3. If I should give you a situation where the observations in the R are 12, the observation in the W are just 2, and the observation in the E are just 30. So they all have different sample sizes. You will have different answers if you use the 2 approach. But the better approach is when you add all the observations and divide by the sample size. So please note that is how you find the grand mean. Don't use shortcuts to find the grand mean. Okay, now that you have gotten these values, you can now substitute them one by one. Yes, Agnes.
Sir, can you also look at the mean that you've calculated for each group and then just take the value from there?
Well, Agnes, if you are here, that's exactly what I was just talking about. And I was saying that that is a wrong approach. I've said that multiple times. That is what your good friend did. He added 2 plus 5 plus 8 got 15, divided it by 3, and I said that approach is wrong. So you cannot do that.
That's not the same thing I'm saying. I'm saying just by looking at it, we have 2, 5, 8. And so you just pick the 5 is.
Well, the numbers that is, what if the first one was 1, 2, 3, 4, and the other one was 15, 16, 17, 18, and the other one was 30, 100, and 200. Is that what you would have done?
Okay, no, all right.
Okay. So you get it. So life is not a straight line as this one is. So in real situation, and I'll give you an example when we get to the end. In real situation, they are not 1, 1, 1 interval between them. Now, this data was made simpler. All right. So now we can calculate our SSG. Look at the formula at the top. The formula for the SSG, this is the formula. It says that take the sample in the first group. So the sample in the first group is what? You can tell me the sample in the first group. Agnes.
7.
No, the sample in the first group. Let me go to another person. Eric.
3.
3. So Agnes, if you count the sample, you see that the first one is 1, the second is 2, the third is 3. So the sample in the first group is 3. So that's what you're going to write first. Okay, so you're going to write that first. So let me put that here, 3. Then according to the formula, bring a bracket. Okay, bring a bracket, close the bracket, and square the bracket. What should be inside a bracket? It says that the mean in the first group minus the grand mean. We know that the mean is 2. The mean is 2. And the grand mean is 5. So what is going to be in the bracket is 2 minus 5. Okay, you're going to find the answer. Then you do plus the second one, the second group. It says that take the sample in that second group. It also happens to be 3. So you're going to do 3 into bracket, what minus what square? 3 into bracket, what minus what square? You can tell us. Valentina.
5 minus 5 squared.
Very good. 5 minus 5. Then you do plus. You go to the third group. And the third group is going to be the same 3. And then something squared. What minus what square? The third group. It will be what minus what square? Elliot.
8 minus 5 squared.
Okay, so you have 8 minus 5. I want you to find me the answer to all this. If you are ready, you raise your hand and tell me the answer for this. Elizabeth.
54.
Exactly. So when you do all of that, you're going to get the value of 5,4. That is your first important answer that you need to document. Once you have that answer, you have to go back to the table and fill in that answer. So where do we go? You go back to the table here and write 54. That is a SSG. Okay, it's not clear. Now we go to the second thing to find. And the second thing to find is a SSW. SSW. Now, how do you find the SSW? Well, that is also a formula. Okay, please put in all the answers I'm deleting from in your head. Note them down. The SSW is also a formula that you need to be able to identify. It's a formula which is given by SSW. That is summation X I J minus X I bar all squared. Sij minus Si bar all squared. So you write it down first, write it down. See, sometimes when you see some of this formulae, it sounds and looks like Hebrew. Somebody even thinks like it's a combination of Hebrew and Aramaic. However, as you go through the example of it, you realize that it's nothing big deal. So just write it down first. That's the first step. Okay, so what is Xij? Xij simply refers to each of the numbers. So the number 1 that you see here is Xij. Number 1 here is Xij. Number 2 is Xij. Number 3 is Xij. 5 is Xij. 9 is Xij. So each number is Xij. As for the second number, which is the mean, we know what that is. We know that that is the mean in each group. So the formula says that take the number in each group minus that mean in that group and square it. Then add it to the next number and square it. Because the groups are 3, I'm going to work the group 1 for you. So let's call the group 1 SSW1. So you will take the number 1 minus the mean in that group. What was the mean in that group? 2. So you write 1 minus 2, then you square it, plus, still in that group, 2, which is the next number, 2 minus 2, because 2 is also the mean. So you do 2 minus 2, then you square it. Then lastly, the last number in that group was 3. So you do plus 3 minus the mean, which is 2, and then you square that as well. If the observations are many there, you will finish all of them. And that is what you do for the first group. Now the rest is your calculator. 1 minus 2 is minus 1. Okay. Minus 1 square is 1. 2 minus 2 is 0. So the middle number is 0. 3 minus 2 is 1. 1 square is 1. So you add this 1 to the first one, and therefore your SSW is going to be 2. Now, I want you to find the SSW2, and then find the SSW3. When you are done, add all of the 3 SSWs together and tell me, finally, the total SSW. So do that, and please send me the answer privately. Send me the answer privately. Look for my name in the chat and please send me the answer privately. I'm just taking the first 20 answers that are honestly correct. All the formulae will be given to you in an exam. All the formulae will be given to you in an exam, so don't worry. Jochebed, the answer is correct. Serum is correct. Georgette, you are correct. Joshua, you are correct. Agnes, incorrect. Amwenima and Eric, Ruby, Betty. Betty, you are wrong. Amwenima, you are correct. Eric, you are correct. Ruby, you are correct. Nico, you're correct. Valentina, correct. Marilyn, correct. Elliot, wrong. Amanda, wrong. Patience, wrong. Unique, wrong. Sandra, wrong. Ian, wrong. Stephen, wrong. Kennedy, wrong. Lasisi, correct. Abba, correct. Julie, correct. Now I got my 20 people, so I've added stop to everyone. Very good, very good, very good.
Group 2 is 2, and you said I'm wrong.
I didn't say do group 2. If you look on the screen, I was very particular in saying that do for group 2 and group 3 and add all of them together, and then you tell me your final answer. So you are supposed to do everything, add all together, and tell me the final SSW. I didn't say do only group 2 for me. So that is where the challenge for you was. Okay. So the rest of you are coming along. That's fine. You're all doing well. Esther, you are doing well. All of you, Frida, Alima, Patience, Ajwa, all of you are doing excellent answer. The only thing is I wanted the first 20 people. Okay. Gifty, your answer is not correct. Okay. So guys, if you are using your mind, it's not good. You have to use your calculator. If you do for SSW 2, you get 2. If you do for SSW 3, you also get 2. So now, to get your final SSW, all you have to do is to add the 3 numbers, 2 plus 2 plus 2. And that is what gives most people the correct answer of 6. So if your answer is not 6, you are wrong. Your answer is supposed to be absolute 6. So that is the SSW. In fact, in an exam situation, for example, manually computing, this is the most difficult one to compute. It's not the SSG, it's SSW, simply because it's quite a lot. But we have found it here. The value for the SSW is known as 6, number 6. So you write that down in the space there, number 6. Now we are ready to find the next chapter of our answer, and that is the degrees of freedom. There are 2 of the degrees of freedom. We have the numerator, which is the k minus 1, and then we have the denominator, which is the n minus 2. That's all you got to find. What is k? K is a number of groups. It's written down there. K is a number of groups. So who can tell me the value of k? Raise your hand and tell me the value of k. Ajwa.
You said k is what, please?
Ajwa, what is the value of k?
Say 3.
Okay, good. So k is 3, that is correct. So what would be the degrees of freedom for this numerator value? What would be the, Sandra, what is the degrees of freedom?
No, sir, please, I didn't get you the explanation for the k.
Sandra, I can't hear your voice.
K means what K is. I didn't get that one.
The total
Thanks.
number of groups is written down here on your screen. The
Okay,
total
all right.
number of groups, and there are 3 groups.
Thank you, sir.
So, Frida, tell us the answer for the k minus 1.
2, please. 2.
Very good. So the value here is 3 minus 1, which is 2. Okay. So the value for this is 2. What do you think is the value for n minus k? What do you think is the value for n minus k? Elizabeth.
9 minus 3, which is 6.
I was waiting for that to complete it. So the value for the n minus k is 6. So that's it. You're done. These are the two most important things to find. Now that you have found this, the rest is going to be easy peasy. The next is to find the MSG. The MSG, to get it, is simply the 54 by the 2. And the MSW is simply the 6 by the 6. Okay, so what is the value of the MSG? You can tell us. What is the value of the MSG? Bridget.
Please, 27.
And what is the value of the MSW? Felix.
1.
All right, okay. So you get the value here to be 27, which is 54 by 2 divided by 2. And then 6 by 6, that will give you 1. Now, finally, our F statistic, as you see, it is the value you found at the top here divided by the value you found at the down here. Therefore, our F statistic is equal to 27. So 27 is the F statistic, the F calculated, the test statistic. The next is to find the critical value. Okay, it was all part of the step 2, finding the critical value. How do you do that? How do you find the critical value? Well, that is fairly simple. To find the critical value, you got to use a formula. It's a very simple formula, and it's come from something we have already calculated. The F tabulated, because that's another name for the F critical, is given by F subscript alpha, comma, K minus 1, comma, N minus K. Okay. So that is the F statistic. I am F critical. If alpha is not given, then you use the default alpha of 0.05. Okay, that's what you use. We already know. So now we know that the alpha, yes, Ajwa.
Sir, please, can you come again with the formula for the F tabulated, F critical?
The formula is given by F subscript alpha, K minus 1, N minus K. By the way, that is the same thing in your screen, your formula book. That is the same thing under the degrees of freedom here. The same 2 and 6 that you found. So the K minus 1 is still that 2. And then the N minus K is still that 6. So you just have to use your F table, locate the 0.05 and match the 2 against the 6. How do you match the 2 against the 6? So it means that the 2 must be located somewhere and the 6 must also be located somewhere. So how do you do that? This is in your table here. Okay. Let me see if I can take out this. So in this table that you see, the table is made up of, but usually there are 2 tables. One is 5%, one is 1%. The one on your screen here is 5%. So now that you know it's 5%, okay, you just have to identify the first number. What was the first number? 2. What was the second number? 6. So how do you find it? So at the top here, at the very top, that's where you find the first number. The first number is at the very top. And then on the far left, that is where you find the second number. So the first number is 2. So you identify the 2. The second number is 6. So you also identify the 6. Where they will meet, that is where your answer is. Please privately text me the answer where they will meet. Privately text me the answer where they will meet. I'm giving 1 mark to the first 50 people.
Sir,
Yes.
you said the first one meet at where and the second one is?
You identify the first one at the very top of your screen, the top numbers, the top yellow numbers,
yes,
the top numbers in the yellow line.
Yes.
And the second number, you identify it on the numbers in the far left yellow.
Yes, please.
All right. So when you do it well, I'm getting some good answers from almost everyone. You'll get 5.14. That is the value of the critical value. So we have been able to get the F statistic to be 27. Don't forget that. Okay. The statistic is 27. And then the critical value is 5.14. For this level, for this part, I will not bore you to find the p-value and alpha like the other ones. So we are going to go straight to the conclusion. Now, first, the decision rule. The decision rule in the F test is the same as the decision rule in the T test. So note that now. The decision rule in the F test is the same as that of the T test. So who can give me the decision rule in the T test? What does the rule say? I know some of you are flipping through your papers. I know that you are going through your papers to be sure what you're coming to say is correct. Sarah.
Hello, Prof.
Yeah.
Okay, so reject the null hypothesis if the F calculated is greater than or equal to the F tabulated.
Super. Excellent for 2. So that is the right way. Reject the null if the F cal is greater or equal to the F tab. So who can install that in our analysis here? Should we reject our null hypothesis here, or we don't reject, and why are you saying that? You can tell me the conclusion for our example. Should we reject the null hypothesis or we don't? Yes, Eric.
Okay, so let me try. So we do not have to reject the null hypothesis because the F stat is lower than the critical value.
What were your answers? What were your answers for the F stats and the critical value?
The F stat was 5.14, and then the critical value is 6.
Are you sure of what you're saying?
Yes, sir.
That's wrong.
Okay.
So check your notes and you will know the value of the F statistic. Yes, Sarah.
Okay, so since the F calculated of 27 is greater than or equal to, is greater than the F tabulated of 5.14, we do not, we reject the null hypothesis.
Say that again.
Since the F calculated of 27 is greater than the F tabulated of 5.14, we reject the null hypothesis.
That's it. That's it. That's a very good conclusion. So you will say that since the F statistic of 27, by the way, Eric, the F statistic is 27, is what we all calculated from the, and then put it into a formula and all of that. That's what we did together. So you say since the F calculated of 27 exceed the critical value of 5.14, we reject the null hypothesis at the 5% level of significance. We reject the null hypothesis at the 5% level of significance and conclude that a statistically significant difference exists. A statistically significant difference exists in the mean salaries. A statistically significant difference exists in the mean salaries across the MBA groups, across the 3 MBA groups. That is how you do your conclusion. I'm saying this conclusion because it carries 7 marks. Okay? And so it's important to learn how to write this conclusion. But I'm not finished. Since the F statistic of 27 exceed the critical value of 5.14, we reject the null hypothesis at the 5% level of significance and conclude that a statistically significant difference exists in the mean salaries across the 3 MBA groups. Therefore, the lowest salary is, who can tell me the lowest salary? Which group earns the lowest salary? Frida.
Regular, please.
Good. And what is their value?
1,000.
1,000. Do you say 1,000? What is their value?
And that would be 3,000.
3,000. Are you sure?
6 divided by 3, 2,000, sorry.
Someone.
2,000, 6 divided by 3, 2,000.
All right. So the EMBA can be set to now and the lowest salary. Okay. So guys, let me ask you, if I had not rejected the null hypothesis and I had said which group earns the lowest salary, what would you say? If I had not rejected the null hypothesis and I have asked which group earns the lowest salary, what would be your answer? If I had said which group earns the lowest salary, and it is clear I have not rejected the null hypothesis, what will be your answer? Okay. So you will say that none of them earns the lowest salary, because whatever difference you find there is not statistically significant enough to warrant a rejection of the null hypothesis. So there's nothing to reject at that point in time. And that is why it therefore means that you do not have any answer to give me. Yes, Agnes.
So please, I had an issue with my internet on the lower salary when it got to the lower salary earners. I didn't get what was said at the time.
One of your friends said that the firm earning the lowest salary is regular MBA. That's what he said. And that was a correct answer.
And then you mentioned an amount. That what was the amount?
The amount is the mean value, which is 2,000.
Oh, okay.
The highest salary is EMBA. The amount is 8,000. The lowest salary is regular MBA. The amount is 2,000.
All right. Thank you, Doc. Thank you.
Okay. So, ladies and gentlemen, that is how you got to do ANOVA Master 8. Let me show you something here. Master the ANOVA Master 8. Now, let me see if I can show you this. If you check your slides, you see that everything I've said today, they are there. Everything is here. Okay, it's all here. You go through it, you see that everything I've saying is here. It's all written here. The SSW1, SSW2, SSW3, all of them, they are here. So just go through things and then you can say that you did your best. All right. Now, I want you to please open your R Studio. I want you to please open your R Studio because you're about to do something very important. I am doing what I'm doing with this R here because you have an assignment. And that assignment, even though you're going to do it in groups, you will have to write a lot of R codes and interpret some of the results. So what we're about to do here, if you follow it very well, you will be able to run your codes and interpret your codes. Regarding the complaint before and the complaint after data, I will leave you to go over it yourself. After I've gone through one with you, which is the Brukutu data set. I'm going to go through that Brukutu data set with you right now. And then you will now be able to learn from that and use it to do for the complaint data. If there is time, what we did today, the weekend MBA, regular MBA, EMBA, I'll go through that in R with you. All right. So the first thing I want you to do is to open your Brukutu Excel data. This is your Brukutu Excel data.
So please, do we open it in the R Studio where we see Excel? Okay.
So you have the data I sent to you. It should be just like the one I have here. It's called Brukutu for R. It's one of the sheets. Open that. Once you open that, you're about to copy everything in this data set. Okay, move along fast with me. So to copy everything here, you can click anywhere inside and do Control-A to highlight everything. Do Control-A to highlight everything. And then once you have highlighted, do Control-C to copy. Do Control-C to copy. Now go and open your R Studio. And you will see what I'm showing here. So you open your R Studio. I didn't say paste. Don't paste anything. Once you open your R Studio, you will have a command you have typed already, which is gen equal to read.delane bracket clipboard. Click inside that command, that line, click it. Let your cursor be blinking there like mine is blinking. And then once that is done, click run at the top or do Control Enter. Click Run at the top or do Control Enter. When you do that and you come down below the screen, you come to your console, you will notice that the information is written in blue. That shows that everything you did is correct. Okay. All those who have done that, raise your hand.
Please come again with how we should do the gen.
Come again with which one?
Say.
Hello, dog.
Yeah.
Okay, I raised my hand, but I think because of the R studio, you couldn't see. If I named mine a different name.
Don't name anything different. You do yours different at a later time. Work along with my darling.
Yes, Bob. Is there a way to rename it? Or I should just
rename it?
So in loading my file, I named my Jin Brukutu. Is there a way to rename it, or I have to copy and paste it to go with your Jin?
When you say rename it where? Where did you name it Jin Brukutu?
In our studio.
Just go and edit it and call it Jin. That's all. You see the way I've written mine?
Yeah.
Just write it like that.
Okay.
That is what it was in the slides.
Hello, Doc.
Yes.
This is giving me error in eval, something, some red, plenty red writings.
It simply means that first, check your spelling. Make sure that your spellings are just like mine is. Make sure that it's exactly the same thing in the slides. You're not looking at only mine. You have what is in the slides. Check the spelling. Make sure you copy the data, because it's possible that you didn't copy the data from Excel before you came to the R. And make sure that you have clicked that place you want to run. You see, my cursor is blinking under the Jin. Make sure that that is done as well.
Oh.
And don't use capital letters anywhere. Don't use capital letters in any of your typing. Don't write Jin with capital J. No, just do everything small letters.
Okay, so with what we've copied, are we to do anything with it, or you just click in there and then run, and that is it?
That's all. If you have copied, if you have truly copied, just click in the Jin and click at the top, run.
Okay.
Once you click run, ladies and gentlemen, to know that your data is loaded, you should highlight only the JIN, like I've just done. Look on mine. Highlight only the JIN and run again. Only the JIN and run again. You can do run or click Control Enter. And when you do that, your data should be populated down here in the console, like mine is shown. Your data should be populated down here.
So,
you see my data?
I'm seeing it. I'm still getting the same thing. So I'm going to send you a shot of exactly how it's coming, because I'm doing the exact thing you're saying we should do, and it's giving me the same feedback.
The lady who had the problem with the black screen, are you there?
Yes, sir. It's back.
Did you install R first?
Yes, please, but it's back now.
Before you installed R Studio?
Yes, please.
Okay, if you truly did that, you have to reinstall all of them.
Yeah, but like I've got the screen back again. I don't know how, but I got it back.
All right, okay, let's move on.
Hello, sir.
Yes.
Hello, sir. Doc, I did mine differently, but I have the data. I went to import data set.
Please, if you did yours differently and you got it, that's okay. Oh. You don't need to tell me that you did yours differently. And
Doc, I'm saying it because I want to be sure what's
no, you don't have
correct.
to be sure first, because once you follow my approach and you get it, that is fine. But if you did your own approach, I don't know the approach you go on. Otherwise, the next thing you're going to tell me is that I did this and I did this and I did this and I did, and you'll be delaying the rest. If it worked for you, that is fine. Let's move on.
Sir.
That everybody whose own has worked and did it differently is going to verify with me. My dear, if you are sure of what you did, then that's why you are sure of the result. If you can see the result I'm seeing, and you went through a different approach, that means you knew that approach. That is why you went through it. I don't have to come and verify it again. But if you went through the approach I'm giving you and you're not getting the results, then I now come in there to come and help you. Because a lot of hands are at work here and we have limited time. So let me help more those who have not gotten it than to help those who have gotten it.
Sir.
Yes,
Hello,
I do.
sir.
Sir, please, I'll send you a shot of how it's showing on my system.
Yeah, but that's correct, my dear. That's the same thing mine is showing.
No, please, I've sent you on WhatsApp.
On what?
On WhatsApp.
You see, that's why I'm saying so many people are sending me things. So now I need to check WhatsApp, I need to check here, I need to check there, I need to check there, everywhere.
Mm-hmm.
Copy, did you copy the data?
I did.
You know something? Let me see if you can share, because this, see, it makes you so positive that you have copied the data. You are using MacBook, isn't it?
Yes,
you are
I'm
using MacBook, are you not?
Yes, I am.
That's the first problem for those that use MacBook. Before MacBook was specifically told you that X11 module cannot be loaded. Did you see that?
Yes, I'm getting
There's
that.
something you got to do before you can work. If it is MacBook, the way you approach things is not the same as Windows. So my dear, you have to find a way to type that error into Google. Google will tell you something to do, which you have to install before you can see your result.
Oh, wow.
Yes. So ideally, if you have gone through the video and you have contacted me earlier, I would have helped you before today. So that's what you got to do before your MacBook will work.
Okay.
All right.
Please,
Now,
how do you edit? Please, how do you edit the name in the R Studio?
look at mine. Look at mine. I'm just doing it. I go J-I-N. I deleted this like normal word. I type J-I-N. I've just typed it. That's it. It's like normal word editing. It's not magical. Okay, so for those of you who have your screen showing, who see your results, okay, I'm sure we can move on. The next command you are going to deal with is the attach gen command. The attach gen command. So if you have written that already, run it. Nothing will show except the same name, okay, and some few writings, so don't worry. So run your attach gen command. Don't forget to detach. I'm writing a command called detach gen. I'm typing it myself here. So don't forget to detach. In other words, don't forget to run the detach gen when you are done with everything. All right. All right, so now the next thing you want to do is to run the library mass package. Now, The fact that it is library in front of it and there's mass in the bracket means that it's a package. This means that this package must be installed already before coming here today. So if you have installed the package already, and I also posted how to install packages in your group page so that you know and follow how to install packages. Please, all of you, lower your hands for now, because I'll come to the end. Lower your hands for now. So if you have installed a package, just run the command. Click on the library bracket mass and run the library mass package. If you run it, it will show like it is showing down here. It will show blue, which means that it's been run. When you have been able to do that, and it is showing nicely in blue down in the console, raise your hand and let me see. Continue by running the library ggplot2. I'm assuming that you've installed already, so just run that library ggplot2 as well. When you do that, you will notice that it is also showing beautifully down there in the console. Keep your hand up if you've been able to do the two. Okay, very good. So those whose hands are up, I'm working well with you. Okay. Now that you've done these two, you are ready to go to the, and again, I am toggling between the slides. You can have your slides with you and be following what I'm doing. So we are now going to do this command known as table. We're going to generate a table. This table we are going to generate. When you have your assignment, I will ask you to do the similar thing with the new data I'll give you. This table we are going to generate is called a contingency table. A contingency table. We are going to create a contingency table. What is that? Well, it's a table of categorical variables and the number of content, the number of sample size in each of those categorical variables. I have religion, which is inside the data set called gen. I have occupation, shortened by OCC, which is inside the data set called gen. I have location, which is inside the data set called gen. So I'm going to categorize them, and it will be a very beautiful table that you can have several questions around it. So let's do that together. Okay, so let's go to the R, and there you go. I'm running my table. When you run yours like I just did mine, you'll get a beautiful table like you see on the screen. Keep your hand up if you can see yours. Now, let me ask you some few questions related to this. Ladies and gentlemen, you will get a different data set, and I will ask you some questions. But before you can answer those questions, you must also have generated your contingency table or a cross-tabulation table. Okay, you must have generated yours like I've done. So for example, let's just find out some few things in this very example here. You can just shout the answers if I asked you. How many Buddhists were in the rural area? Who can tell me? Based on this, how many Buddhists were in the rural area?
8.
8, very good. How many traders were in the rural area? How many traders were in the rural area?
12.
Good.
How many teachers were Muslims in the urban center? How many teachers were Muslims in the urban center?
4.
Very good.
4.
How many fishes were in the urban center?
4.
12.
It is 12, it's not 4.
12.
And how many Christians were found in the urban center?
12.
12.
Very good. So ladies and gentlemen, if you can be able to generate your beautiful, cross tabulation like this, you should be able to answer this question. So when I ask you those very questions, the only way you can answer them nicely is by creating this table, this contingency table. So know and how to generate contingency table and how to answer some of these questions. Okay? Because you have a lot of questions you're going to answer, but don't worry, you're going to do it in a group. But even though you're going to do this thing in a group, it's also important that you are clear of what you are doing. Okay. All right. Now, the next thing that I want us to do is to go back to our notes. Okay. Let's go back to our notes. Let's go back. You can still have yours in front of you. Okay. We are now going to create some graphs. Of course, some of the graphs that are there are quite a lot. Okay. But when you go through the slide, you see that I've created a lot of graphs. For example, understand all the graphs that I'm about to mention to you. Understand all the graphs I'm about to mention right now to you. Understand when to use them, how to interpret them. I'll do some of them here for you. When to use them and how to interpret them. Okay, so you can take some notes on this. So the first graph is histogram. The second is bar plot. Histogram. Bar plot. The next is box plot. Box plot. Strip plot. The next is strip plot. I'm writing it here. Strip plot. The next is swarm plot. Swarm plot. The next is violin plot. Violin plot. The next is stacked bar plot. Stacked bar plot. The next is line plot. Line plot. Next is pie chart. Pie chart. Next is kernel density estimate. Kernel density plot. Kernel density plot. And then the final one is multiple plots across groups. Multiple plots across groups. So ladies and gentlemen, you got to be used to these plots, know them, understand them, so that you can know how to apply them, because you'll be using some of these, if not all of them, most of them, in your research and also in your assignment that you'll get. Okay, let's try to make sense of a few of them, not all of them, a few of them. Before that, any question? Okay. So the first one that I want us to, and again, you have all of your commands, okay? So you can go through them and run them, but I'm picking some of them. So the first one I want to just run here and show you something about is a box plot. So you see this command I have highlighted. I've written box plot $Q with a tilde sign, $lock, and the color I've indicated rainbow 7. By the way, anytime you use a rainbow color, what the arrow will do is that it will give you any of the 7 rainbow colors, okay, that you are dealing with. But this box plot is what I'm about to tell you something about. So I just run that. I am doing the box plot across location. If you have studied the R data very well, you will see that
I got it.
You will see that there's a column that is known as a location in the data set. Okay. And that column has got 2 levels of location. One is a rural, one is urban. So here is a question that will make you want to draw this graph. The question is, which of them consumes the most gym-bitters? Rural dwellers or urban dwellers? Which of them consumes the most gym-bitters? Is it the rural folks or the urban folks? And comment on the distribution of your result. And comment on the distribution of your result. So the moment you get that, of course, there are several other graphs you can draw, but one of the key ones, I'll draw another graph, by the way. One of the key ones you can draw is the one I have just drawn here to answer the question, box plot. What is a box plot? The box plot is a plot that helps you to identify the shape and the distribution of a numerical data across groups. It helps you to identify the shape and the distribution of a numerical variable across categories. You want to compare the shape and the distribution of a numerical variable across categories. That's a box plot. So if you have not done drawing and I've asked you that which of them are heavy consumers of akpeteshi? Is it the rural folks or the urban folks? What would you have said? Just on top of your head, what would you have said? Oh, you would have.
No, rural.
Rural.
Yeah, that's what you normally would have said. However, what do you see in the graph? What is the graph telling you? Who can tell us something? What is the graph telling you, Richmond?
Those in the urban areas consume more than the rural.
How do you know?
So when you look at the box plot, the yellow, yeah, so when you look at the plot, the box plot, on the right, on the left side, let's say the y-axis, quantity, you see quantity, gene, then dollar sign, then the quantity. So 220 is up there, whilst 140 is down there. And then the yellow one is up. It's more than 180, between 180 and 220. So based on that, I think the urban one, those in the urban areas consume more.
Okay. All right. So based on the answer you gave, I'm coming to do another drawing myself here, because if I had done another drawing, what you said might not hold. So suppose you have a box like this, okay, another one like this. And in this box, and then you have a box like that. Let me show you another box like another box like this. That's the second one. Okay. And then the lines are showing, the lines are showing, the lines are showing, and like this, and like that. And this is still rural. Okay, so this is still R, and this is still U. What would you say? My dear, the same lady who answered, what would you say? Which ones are heavy consumers? Is the lady still there? I'm helping her to expand her mind though. She's run away.
Yeah, my network is not stable, so I only.
Okay.
Yeah, so I'm not able to view. Okay, it's now coming up.
Can you see it now? Okay, so here's a point that I wanted to. Which of you can see the screen? If it is a general thing that I know. Can you see?
Yes, we can.
Yes, sir.
Yes.
You see the little graph I just drew?
Yes.
Yes.
Okay. So the answer she gave is not a good answer. So that's what I wanted her to help her to appreciate it. So who could tell me? Let's go back to this first one. Okay. Which group are heavy consumers of alcohol, of the gym bitters? And why? Oh, she was the only one, the only best person among you. Which group? Yes, Eric.
Okay, so I think the urban group are heavy consumers, and I think the black lines between the in the center of the boxes measures the position, or let's say the frequency. That's to my understanding. So because that black line is between 180 and 220, I assume it's somewhere around 200. It shows that they drink more gin than compared to the rural folks, where the black line is between 140.
Black line are you talking about?
There's a thick black line between.
You are talking the thick black line. So
Sorry,
that is what I wanted her to use. So you are not. She was not supposed to use the box. She said the yellow box is above the red box. But you cannot use the yellow box being above the red box as a determinant of the reason why the urban dwellers are heavy consumers. It's rather the middle line in each of the boxes. Ladies and gentlemen, that middle line is called the median. That is a median. So note something here. Okay, that goes to all of you. Okay. The median, this line here, that middle line here is the median. That's the median. And on top of the box is the 75th percentile. That is the 75th percentile. The bottom line of the box is the 25th percentile. So the box is actually showing 50% of the data. Okay. The box is representing 50% of the data set. Anything after the 75th percentile is an outlier. So one good thing about the box plot is that you can use it to determine outliers. If as at this stage, you don't know what an outlier is, please later Google it. So it helps you to identify the outlier. So anything above this line is an outlier. Anything below the 25th percentile is also an outlier. Fortunately, in both boxes, there are no outliers identified. However, the median of the urban consumers of Jane, the median quantity for the urban dwellers is more than the median quantity of the rural dwellers. And that is why we can say that on average, it appears that the urban dwellers consume more than the rural dwellers because of the median pay. Now, if you look at the one I drew, which I was trying to access, if you look at the two, the median, the boxes are the same. Okay, the boxes are the same. However, the line is higher for the urban, the rural dwellers. The median line is more for the rural dwellers than for the urban. Okay, even though the boxes are the same. Okay. So it is not the boxes, it is the center of the observation. And the median is just one of the center. The others are the mode and the mean. Okay. So that's the first thing you can tell about a box plot. But there's something the box plot could tell you, which unfortunately for this very data I didn't show, and that is outliers. Okay. The box plots can detect outliers. And it's very important to use the box plots to detect outliers, because outliers can be bad sometimes. They can drive all observations to themselves. And it's important to handle outliers when you have that in a data set. All right, so this is just one of the boxes that graphs that we can use to show some few things regarding the data. The density plot, this is a density plot. I use this command to generate the density plot. You can use the same thing. The density plot, if you check it carefully, the density plot, by the way, is like a histogram. It is a smooth histogram. If we go and run the histogram right now, you'll understand why density plot is like a histogram. Let me go up there. This command, hist, and then everything that follows. Let me show the histogram. Look at the histogram. So the histogram shows how the quantity demanded of gene betas is distributed. If you look at a histogram, there are two peaks with a gap in between them. There are two peaks. For example, between 160 and 180 quantity demanded, there are two modes, the green mode and the blue mode. The green mode and the blue mode. And there is a gap, there's nothing in between them. That was exactly what the kernel density was also trying to depict. You see, the kernel density has a peak, and the peak shows the mode. So if I tell you to comment on this kernel density, you will just have to indicate that this kernel density shows the distribution of the quantity demanded of gene betas. And it clearly shows by modality. In other words, it shows two modes. The mode is the most frequently occurring number. Okay. It shows two modes, so that's bimodality in the data set, indicating non-normality. Non-normality. It shows that this data set is not normally distributed. Why? Because in reality, if it was normally distributed, it would be something like this. That is what it would be, normally distributed. Okay. Normally distributed will look like that. Uniformly distributed is like this. Okay. Uniformly distributed is like there is no one that is at peak. Normal distribution, I've got one peak. Non-normal distribution, I've got multiple peaks. Uniform distribution has got no peak. And those are some of the things that you want to be able to use to comment on the data. So it means that if I want to use this quantity demanded for further work, I must accept the fact that it is not probably normally distributed. Okay, so that is how it shows the distribution of the data set. You see, there's one thing showing the data. There's another thing making a sense of the data that you have shown. Now let's go to the next one. The next one There are several of the kernel density distribution you can do. To do that, you should run a command known as require tiger start. I think most of you have typed the command, so you can run them. You see, if you have typed the command, the moment I talk about it, you just run it. Okay, so that's tiger start. Once you run the tiger start, you can show the density plot. Okay, and I just did it. I've shown another density plot. It's just like the previous one, but it shows some beautiful ragnet, okay, down here. It's just a beautification that is here. But more importantly, the most important graph, of course, go and try the others. Okay, if I want to run the others, these are some of them. Okay, this is also another kernel density plot. Okay, this is another kernel density plot. And this is a stacked plot, a stacked bar plot. I told you about it earlier. Okay, a stacked bar plot. What is the essence of it? Well, when you look at the bar plot here, it gives you a feel of two things. One, you will notice that Christians are dominated in the urban center. So if you look at the urban center, the green is for Christians, and they take a chunk of the people who are consuming alcohol in the urban center. The Christians are dominating alcohol consumption in the urban center. There is no Christian in the rural area consuming alcohol. There is no Christian because the green box is not showing. And it appears that the same quantity demanded of gin bitters by the Muslim is the same as what the Buddhists are consuming. Just that in the urban center, But the Buddhists seems to be consuming slightly more than the Muslims in the urban center. But when you go to the rural area, it appears the Muslims are consuming more. If you check the blue is bigger, longer, taller than that of the red. The Muslims are consuming more in the rural areas than the Buddhists in the rural areas. But the Buddhist seems to be consuming slightly more in the urban center than the Muslim. Do you guys follow me? Does somebody follow me? I want to be sure that you are with me, because sometimes you can be lost. Is somebody following? Who is following me?
I'll follow.
Yes,
Yeah, follow.
Very good.
Follow.
Yes, sir.
Very good. It's not for everybody, but at least it's for some people. So, because when you're doing, for example, some of your assignments, it is for some people who will normally lead the group. All right, Ali, you have a question? Ali, your hand was up, or it's not? All right, okay, let's move on.
A thumbs up for the question.
All right, so the next thing to do is, so I've shown you a little bit about stacked bar plot. Please note, you will use a lot of stacked bar plot in your work. Okay, you will use it to answer a lot of questions. You see, I'm just having 3 groups against 2 groups. 3 groups against 2 groups. You can have like 6 groups against 4 groups. So you have multiple bar plots, and you use it to explain your point. All right. The next graph that I want to show you is a strip plot. Strip plot. It was one of the plots I spoke about. And look at the strip plot. It's beautiful, man. It's beautiful. It just goes to endorse the same thing I spoke about. Look at the Christians. They are the green. Yes, Valentina.
Please, which of the commands did you click on to get a strip plot?
It is this command. It is known as multiple strip. It is a command that has gen plot, okay, with a jump point. That is a name. The jump point is a point that brings about the strip, the jump point. So you see that it's probably the only one there that has jump point. The others have different things, but this one has a jump point. It's not jump density, It's not jump violin. It's not jump bar. It is jump point. You see it?
I'm having an error response in the console.
You're having an error. So when you are usually having an error, there are two things you probably haven't done. One, you have not invoked the command known as require tiger start. Or two, you have not invoked the command known as plot2.
I have both installed.
No, you have both. Have you invoked them?
Invoke is you check it, you mean?
Invoke is running it.
Yes.
Invoke means you have installed it already on your computer. Did you install it before?
Yes, I did.
So you went to packages like this,
yeah,
and then you click on install, a pop-up came and you installed it.
Yes.
And then you have invoked it. I know you're going to say yes.
Yes, I have. I had done all that.
So there are two possibilities. Normally, first possibility is that I'm there and then I double check for you. Sometimes there are some. What exact problem do you get? What is that red error do you get?
It's not in red, it's in black. It states error in jump point, problem while computing aesthetics. Error occurred in the first layer. Yeah, that's what's there.
That's all.
Yes.
Okay, so
do
this. Highlight
caused by error.
Highlight the gene and run it and see whether you get the data set below inside this command.
Okay.
Is it done?
No.
What is no?
It's not done.
No, I'm saying that highlight this gene and run it and tell me what you see down there.
Okay, a minute.
All right, let's move on. So the next plot that you got to work on, and is the last plot I'm going to talk on this before I go to the test. And that is the violin plot.
Look, I have what you have. Sorry.
I'm going to run the violin plot. It will take the rest of the time. Since your situation is complex, and maybe at a later point.
Okay.
Now, in this violin plot, and again, I just ran the violin plot. In this violin plot, it is one of the plots that's going to really help you answer probably most of the questions. But of course, the plots will be different. There are three things you got to know about the violin plot, ladies and gentlemen. There are three things you want to know about the violin plot. Number one, it combines the kernel density estimate. It combines the kernel density graph as well as the box plot. So it is showing you both the shape of the data as well as the distribution of the data. It is showing you both the shape and the distribution. The shape and the distribution. That's what it's showing you. Now, when you look at it, and this is very important, you remember that all along, we've been comparing the alcohol consumption between urban and rural folks. And guys, you might remember that I used the median of the box plot to compare the two. Do you remember that?
Yes, Doc.
Yes, Doc.
Yes, sir.
This box plot is the same thing I have here, but it's inside this violin plot. The violin, the nature of the violin is the kernel density graph. That's a normal distribution graph. Of course, it's not normally distributed. That's why you see that there are two peaks. One peak is that, Let me just identify. This is one peak here. This is another peak here. And for this is one peak here. There's another peak there. Okay. So the violin already contains the box plot. So whatever the box plot will tell you, the violin is already telling you. But the violin does more. It gives you more information here, which is beautiful. And that has to do with the probability mass of information. So pay attention and note something. We have already indicated that there are more consumers of alcohol in the urban center represented by this median and lower consumers of alcohol by the rural folks represented by that other median. So if I should compare rural and urban, the urban people appears to consume more alcohol than the rural folks. However, note something. When you look at the urban center, because the thickness or the width of this is wider at the top than at the down here, what it means is that there are more urban dwellers who are consuming more alcohol. There are more urban dwellers who are consuming more alcohol. The alcohol concentration, the probability mass is higher at the higher value of above 200. But those that are rural folks whom we said they consume less alcohol, the volume of the consumption, even though they are consuming the people, okay, even though the alcohol that they are consuming is less compared to the urban, the volume of consumption of alcohol is still great because the width of the plot shows that there's a higher probability mass of consumers of alcohol at the base. So it's like somebody who is telling you that I don't eat fufu, okay, but I eat banku. But the quantity of banku that the person is eating, if he had eaten fufu, is even better. That is what I mean. So what the violin plot is telling you is that it's giving you further information among the so-called rural folks who are saying that they don't consume much alcohol. Even though they don't consume much alcohol compared to the urban, those who consume the alcohol consume lots and lots of alcohol. That is the point we are saying. I'm done. If you don't get it, you can let me know. So when you are describing this with a violin plot, do not only talk about the median, but also talk about the probability mass, whether the median is in a lower probability mass, okay, than, or it is in a higher probability mass. Whether the median is in a lower probability mass than in a higher probability mass. If you are able to do that, it brings home a very nice interpretation of the box plots that you are dealing with. Any question? Any question before I move on? So just know that you'll be using the violin plot to describe the shape of the distribution, the shape of the data, as well as the distribution of the data set. It's very important. There are some few things. Yes, I have some hands up. You have favor.
Yes, Doug. Doug, my question is that when you type it and you are getting error, how do you correct this error? Do you repeat the same line? Because I try it.
Most of the time, when you are getting the error, there are two possibilities. There are quite a number of possibilities. But one of the first thing I noticed is that the person may have made typographical errors.
Yes,
R does not like capitals when the capitals are not supposed to be used. If one is typing and makes a comma instead of a full stop, it will also punish the person. If you did not install a package before you run the command, you will get an. So the first thing is that every spelling must be exactly as it's supposed to be.
Yeah.
Then the second thing is I make sure that you are using small letters where there's a need for. The reason why I use a capital Q here is because in the Excel data, when you go and check the Excel data, I had used the capital Q there. And because I was bringing that Excel data into the R, that is why I have to maintain the capital Q. If you go to the Excel here, this is my Excel. You will notice that I have Q, capital P, capital C, capital M, just as it is. So in that case, when I go to the R, I have to maintain them if I'm referring to those. Okay. Other than that, everything that I'm typing is supposed to follow exactly as it is. And again, finding a wrong result, it doesn't mean anything. It doesn't mean that you are wrong or you are not good or anything. It is normal. It is normal for you to make mistake in R when you are beginning. It's so normal. When I was starting, it's so frustratingly normal. But as you get used to it, sometimes you go and check underscore. Instead of underscore, you wrote minus or hyphen. Yeah. Okay. Sometimes there's a bracket. Okay? You make a double bracket. Sometimes it will warn you. For example, let's watch something. Suppose I bring a bracket here. I brought a bracket. Okay. Just watch. I just brought a bracket, but I have no closes. So when I go to the next page, it will even give me a clue with the times that I've made a mistake already in the work. So, but when I go back and remove that bracket, which I've just done, now it is telling me that everything is fine. So typos are very, very key. That's the first thing you want to check. And you want to ensure that, you want to go through and ensure that everything is as exactly as it is. If I am in front of you, I can detect it quickly.
Okay.
Okay. I will know that you are not invoked a package. Okay. And that is why that is happening. So it's not really getting the result, but it's like trying to make sure that you have followed all the packages that got to be installed before you move on. So when you go to the slides, you notice that I've indicated that install the library math and load it. Install the GenGen plot and load it. Install the Tiger start and load it, and all of that.
Sir, please, I have a question.
Yes.
Thank you.
I'm trying to install the ggplot 2, and it says updating loaded packages. One or more of the packages to be updated are currently loaded. Restarting R prior to install is highly recommended. Yes, no, cancel. I don't know what to do.
You have to restart. First of all, you are installing it here, so it makes it a little bit difficult also, because you may have run some things before you are installing. It would have been nice that...
In fact, I did that yesterday, and I experienced the same challenge. So I already thought I'd installed it.
What challenge did you experience?
The same message came up, so I didn't do anything about it. The same R Studio can restart R before installing the requested packages.
R Studio can what?
R Studio can restart R before installing the requested packages. All work and data will be preserved during restart.
Oh, don't worry, you restart it. Just click restart, and when it says save, just save it.
Okay, all right. Okay.
Just save it. I hope by now you have named your data, your document.
Yes, I have.
Just save it and reopen it. And when you reopen, you don't go straight to that point. You have to start all over again.
From Gen.
From Gen, exactly.
Okay, all right. Thank you.
Yes, Eric.
Okay, Doc, thanks. So it's two questions. First of all, maybe if you enter double space, can that also generate an error?
No, and double space will not punish you at all.
Okay, all right, thank you. Please, the second question I would like to ask is the interpretation of the what's the name? This particular chart we have, graph we have here.
Yeah.
So you mentioned that with the rural group, even though when you compare to the urban, they consume less, but the individual consumption is high. I want to know, like, will we be given a base figure to determine that theirs is also very high? Because when we compare the two, we can easily tell which of them is higher. But how do we determine that an individual group has a higher consumption? Is it because of the shape of the graph, or we have a particular base number where we can say, okay, when they reach this particular number, then we can say they also consume more?
No, it's not a number because everything is graph. It is how wide the thing is. So if you look at, suppose the green line is not there, okay? It's just a red violin, right?
That's it.
Now, just a red violin, forget about urban, just the rural. If you look at the top part here, you see that it is not wide. From one end to the other, the horizontal line is not wide. The weight of the density, okay? So you see the density plot is this part. You see the funo, that's a density. So the density here compared to the density here, the one at the bottom has a wider density than the top one. You see that? Do you get what I mean?
Yes, please. Yeah.
Good. So there is a probability density function here. And this whole thing, which is looking like a mirror, that is a probability density function, which is essentially a very rotated, smooth histogram. That's how it is. It's a very rotated, smooth histogram. And it shows the shape of the distribution or the shape of the data. Now, usually, when it is wider, as you see down here, okay, you see that this part is wider. What it means is that the people who are consuming more alcohol, you know, the people consuming more alcohol are closer to 200 than 150, isn't it? Do you get it?
Yeah, yes, Doc.
They are closer around 200, so they are here. They are consuming more alcohol than those that are, but the people there are not many. Okay. In other words, the people who are consuming more alcohol are not many at the top. Okay. So it's like the rich being rich. So it's like you have a very, a country with so, what do you call it? With rich people, with billionaires. But the billionaires are not many. And they are the ones here. And majority of the people who are not billionaires, they are just 150,000 people, okay, NS, they are rather circulated here. And that the fact that this one is bigger than the one at the top means that there are more people who are consuming alcohol at 150 quantity than there are more people who are consuming alcohol at 200 quantity.
Okay.
Does that make a bit sense?
Yes, please. That is fine.
So the wider, the more concentrated the probability mass. And that is why I sent you guys some pictures just for you to, I posted it on the page actually, for you guys to go and check that. And here's the thing, a violin plot is a very powerful data visualization, chart. And whenever you have a violin, two violin plots, and you are comparing them, you have to just compare the medians. That's one. And I know that one you understand. Then you compare the concentration of the probability. Okay. You compare the two data sets, how one is concentrated than the other. Okay. So you may have one subpopulation of the data point, that is more concentrated than another subpopulation of the data point. Now, this is after you have compared the medians. Then the next thing to do is to compare the probability density. And that one will indicate. So what I'm saying is that those who consume, the green guys are the urban. Those who consume alcohol, they are quite a lot, okay, at the median here. They are quite a lot in the urban center. And they are also the dominant people. They are not jokers, so they are consuming alcohol, but they dominate. There are more people who are consuming alcohol at a higher rate than there are more people in the rural area who are consuming alcohol. That's the point I'm saying. In other words, the people who are in the urban center, who are consuming higher volume of alcohol in the urban center, the people who are consuming the alcohol in the urban center consume higher volume of the alcohol than those in the rural sector who consume even higher, who are highly consuming alcohol. They don't consume higher volume of alcohol than those in the urban sector. I hope that is a bit of it.
Yes, please. Thank you.
So the next thing you want to do is to just go and Google a little bit more about interpretation of Boolean plots. Okay? And that helps you to know that the Boolean plot combines the strength of the box plot with that of the histogram or the kernel density estimation. And it does that by using that smooth probability density function. Because when you should use the histogram, I didn't use it here. When you use the histogram incorporates subjectivity of the binning, because that one uses bins. If I should go back here and show you, you see that. Okay. There's that. The histogram uses bins. There's that. There you go. Show somewhere. Yes, the histogram here is using bins. And these bins, you look at the bins, they are all of the same size. Every bin is the same size. It's just a height that is different. So if you look at even the purple, this red and all of that, what can you even say about them? You are likely to say that they are the same. Okay? So there's a lot of subjectivity of the binning in histogram, unlike the Boolean plot, which even has box plot in it. So it will give you the first quartile, which is a 75th percentile. It will give you the third quartile, which is a 25th percentile. It will give you the median, which is a 50th percentile. If you look at a histogram, it's not giving you any median. It will give you the maximum value, because when you go to the box plot, the Boolean plot, which contains a box plot, it will give you the maximum value and the minimum value. I didn't explain all of this because I want you to go and learn some of these things. Okay. This is the maximum value. Okay, that's the maximum value you see there. That's the end of the line. And then the minimum value is the bottom end of that blue line. Okay. So it gives you both, but the histogram doesn't give you. So the Boolean plots are a greater way of visualizing a lot of multimodal data. That is data that has, two or more mode. And you can see that this one has two or more mode. This is one of the mode here. There's that. That's one of the mode here, and that's one of the mode here. Yes, Eric, your hand is still up.
Okay, Doc, please. So when we look at the plot, we see that beyond the straight line, that's the straight lines on the box plots, there is the drawings goes above. That part, does it also shows that some part of the population is there? Do we call that an outlier, or it doesn't hold in that case?
Good. So the box plot should show, first of all, the box plot outliers end there. It ends at that blue tip. Anything about that, the Boolean is telling you the possibilities. Okay. So Boolean, the fact that you see some of the things, the Boolean going further, means that he's telling you possibilities. You see, the Boolean is not telling you whether it's there or it's not there. It's telling you the concentration as well. So you can be there, but you can be highly concentrated. Let me give you two examples. One, you can have ages of 10 people. 9 of them are all aged between 5, and 6. So these are like toddlers. 9 of the 10 people are all aged between 5 and 6. The last person is 98 years old. If you are to find the mean of this data, what is it likely to be? Either.
Please come again.
Doc, please, I'm here.
Please come again.
Hey, you vanish all of a sudden. I said that there are 10 people. 9 of them are aged between 5 and 7. The 10th person is 98 years old. If you find the average or the mean of their ages, what are you likely to get? Are you likely to get around 10 or around 40, 50?
We'll get around 40, 50 because of the 90,
Good.
the 95.
So you see, what the 90 is doing is that he's distorting the data. So that 90, so you see that the 9 people, they will all be here. They will all be at the bottom. So the curve will bulge out. The volume will bulge out because they are concentrated there, but they are the lower portion. But that guy, that 98 guy can drive the mean to itself, isn't it? If you go and ask all the 9 people, they'll tell you that none of them is even around 40 years because they are all toddlers. But that 98-year-old person can drive all of them. So this tip here, it's showing the possibility of the outlier driving the concentration to itself. That's all it's trying to show there. Okay, it's trying to show. It doesn't mean that there are other outliers there, but it simply means that this very last outlier, its capability of driving the concentration to itself, that is what is going up there.
Okay. All right. Thank you. Thank you.
All right. Let's move on to the latter part for today. So go and play with some of these graphs. Okay. Let's go to the test. Once you have shown the graph, the next thing to do and the last thing to do is to test. Test. Let's go to the slide and you see some of the test questions I asked. I'll just look at 2 of them. Just 2, okay? Because I know that when sometimes some people are slightly, hungry and want to eat, their concentration level is diminished by 48 notches. So here is a question. This question will require that you use 2 samples. Is there a statistically significant difference in the quantity demanded across location? In other words, do rural folks consume more alcohol than urban folks? That's a question. And it says that assuming normality and independence. If you are assuming normality and independence, then what it means is that you have to use the independent t-test. Remember the table I showed you last week? Independent t-test. So I'm going to do this in R. How do you do it in R? The question follows that which location type is likely to demand more gym bitters? Which location type? To run this thing, you have to do the independent t-test. Okay. Now, I've already done the dependent t-test here, but that's not what you are doing. But I've just done that here to show you how to do that one. But the most important one to do for this is the independent t-test, which is this one. How do you do that? Go to your R, okay, result, and you will see that that independent t-test is this. This is that independent t-test. It is t.test, gin dollar killed, the numerical variable you are comparing, and then gin dollar location. Once you select this location, R will automatically detect the 2 levels of location, rural and urban. And we are going to use the test, which is known as the Welsh 2-sample independent test. That's it. Let me run that and see the results at the bottom. Look at the results at the bottom. The beautiful thing about the results is that it will tell you something. First of all, it will tell you what you are dealing with. You are comparing quantity across groups, across location. It will give you the test statistic. And this 6.28 or 229 absolute value. It will also give you the p-value. The most important number you want to look at is the p-value. And check whether that is less than 5% or more than 5%. Ladies and gentlemen, if you look at this value, is it less than 5% or more than 5%? You can tell me. You can tell me, is it less than 5% or more than 5%? Selassie. Agnes.
So it's less than 5%.
Very good. How did you know?
Said that it's just by observation.
Oh, yeah. If your colleague asks you, how did you know? You tell the person it's just your observation.
Just
it's lottery. The one you say that it means you did lottery.
Well, like I said, I don't want to mess my answer up.
All right, okay. Let somebody guide you. Let somebody guide the guy. Ali.
Yeah, so it's to the power -7.
What does that mean?
Oh, it means that it's been rounded up to the power -7. So if I'm
repeating the same thing. If you are teaching a 6-year-old, is that what you would say?
Oh, well, then I'll write it like this.
You write it. Okay, so write it how it's supposed to be, and let me see.
Okay, so it will be 0.00000. So 6 zeros, 2.303.
You don't bring the point again.
No, sorry, 303.
Okay. So, ladies and gentlemen, what it simply means is that when you're interpreting it to somebody, you should just tell the person what this means is that there are 7 zeros before the 2. There are 7 zeros before the 2303. That's all. There are 7 zeros before the 2303. Okay, so this means that this number is approximately 0. That way the person should get it. And the fact that it's 0 means that it's less than 5%. If it is less than 5%, it means that we reject the null hypothesis. That's what it always means. If it's less than 5%, you reject the null hypothesis. Write it down. That's what you want to write down in your note. Anytime it's less than 5%, it means that our actual error is 0. Yes, Ali, your hand is still up. Is your hand? Okay, all right. So now that we know that it is 0, what would be our conclusion? It means that there's a significant difference in the quantity demanded between the rural and the urban folks. But now, which one is consuming more? Come down here and come and check the mean. When you check the mean, you will notice that the urban are consuming a mean of 196, and the rural are consuming a mean of 154. And since the urban number, the mean, is more than the rural, and we have already concluded that there's a significant difference, we can now say with statistical authority that the urban people significantly consume more alcohol than the rural folks. Significantly is a powerful word because we have done a statistical test to back it. So if you see something in an exams, if you see that I've given you a data set and I've given you this whole result, and I tell you, draw your conclusion based on the results, these are some of the things I'm expecting you to say. Draw a conclusion based on the results. Okay, so this is just for 2 samples, urban and rural. That's all. That's all we just did. 2 samples, urban and rural. But what if we are dealing with 3 samples, like the ANOVA we did today? Okay. What if we are dealing with 3 samples? How will it look like? Look at this question. 3 samples. By the way, go and check the other ones I didn't show, the Wilcoxon that I didn't show. Okay, so 3 samples. okay, like the regular MBA and all of those ones. Okay. But I want to go 3 samples using the ANOVA. You see, you remember ANOVA deals with 3 or more samples. 3 or more samples. So I have to look into the data and look for those that have 3 or more samples. Religion has 3 or more samples. So I'm going to do the ANOVA for religion. So this is how you write the command. Let me show you here in R. Ladies and gentlemen, this is the command, ANOVA. Okay, look down here. You have the ANOVA command, the 3 samples. How will you do the test? This is the test. This is the test. I'm highlighting it for those of you who can't see. I called it R equal to AOV. R equal to AOV. AOV means ANOVA. And I said, I'm trying to see how quantity demanded differs across religion. R already knows that REL is religion, and there are 3 of them. And then I bring a semicolon here, and then after the semicolon, you write summary of the R equation that you gave. So summary of the result, that's what I want to write. Let's run that. Remember, this is independent ANOVA. 8 non-parametric versions are those down here. Okay, all right. So let's run that. And now that I have run that, look at the result. Again, don't bother too much at making too much sense of the results. Just look at the p-value. The p-value is always the last one here. The p-value is always the last one. What does the value of the p-value mean? I think Ali has helped you guys. What does this value of the p-value mean? What does it mean? Salasi.
It's less than 5%.
Yeah, what is the value? What is the actual value? It's approximately what value?
Okay, as like Ali said, that's the 10 zeros before the 1.
So it is approximately what value?
0.
That's it. That's all I need. Okay. So this value simply means 0. What does a 3 star mean? The 3 star means it's significant at 0.1%. That's this. Take note, because there's a question I have for you on that. What does a 2 star mean? The 2 star means that it's significant at 1%. In other words, there is a significant difference at 1%. What does a 1 star mean? The 1 star means it's significant at 5%. So what does this all mean? It means that there is a statistically significant difference in the quantity demanded of gene betas across the 3 religions. There is a statistically significant difference in the quantity demanded of gene betas across the 3 religious groups. That's what it means. But the question is that, how will you be able to find the mean? How will you be able to find the mean? Because I would wish that I can find the mean to know which one is bigger. So one thing you can do, but I didn't show you guys there, you can just do describe by, and then do, what do you call it? Quantity demanded. Let me just write it here. Describe quantity demanded by religion. Let's see if it works. So you see, that didn't work. I just need to bring $G in front of each one of them. $G and then $G. Maybe it won't work because I have to go and invoke psych. So when you guys sometimes do the thing and it doesn't work, it doesn't matter. It just means that you just need to. So invoke a command called psych, or what do you call it? Library side. Okay, let me run that first. And then, oh, let me see. This. Okay, so this here. Oops, 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 oops. Describe, come on. All right, so this is what I want to. All right, so that's it. I just hope that you could see what I am doing. So describe by gene, then gene religion, okay? And then I show this. There you go. So what it does is that it gives you all the descriptive statistics for each group. So from here, you can pick the mean quantity demanded for Buddhists. That is 180. You can pick the mean quantity demanded for Christians. That is 206. You can pick the mean quantity demanded for Muslims. That is 147.5. And since the Christian one is the highest, you can say that Christians significantly consume the highest quantity demanded of gene bitters, which is equal to 206.67, because you have found the mean to justify it. So which command did I use? This is a command that I used for that purpose. So ladies and gentlemen, you should be able to now go and in your groups, start playing along with these commands. I have a Kruskal-Wallis here, you can check. Kruskal-Wallis is used when the data is independent, it's here. And it is also non-parametric, take note. Okay. And Friedman is when the data is independent, it is non-parametric and dependent. But it will not work on our religion data because for it to work, all of them must have the same length. They must all be 12, 12, 12, or 6, 6 is the same length. So it is for paired data, like our complaint before and our complaint after. Very good. I have some examples here for you at home. Go through it. It's just like my own, just that the sample size is slightly different from the one we did today. And I also have another one here. Okay, it's about issue. Okay, this one, the sample is more than the previous one, is bigger than the previous one, and the data is not balanced also. Yes, Eric, your hand is up.
Thanks, Doc. Doc, please, when we see the code, I just want to ask a question on the code, like when to use the dollar sign. So I wish maybe we can see here, so something like the dollar sign and then those symbols. I think there's a curve. We have dot at somewhere. Let's say the Kruskal, and then we have the dot and tail. Like when to use those.
Those values are automatic in the memory of R. Once you start typing, it will show you. Let me give you an example. Suppose I start typing, but you should know that already Kruskal-Wallis is used in the, whenever you are dealing, you should know already when you want to use Kruskal-Wallis. You only are using it because you know your data is 3 or more samples, okay? You also know that your sample is independent. This is already given in the table I showed you earlier. And finally, the Kruskal-Wallis, I'm going to use it because the data is not parametric. Once you know that you have 3 or more samples, and you have been told that you should check whether there's a significant difference, you will ask yourself the question, okay, so these 3 or more samples, are they parametric or non-parametric? Once you know that the numerical variable you are comparing is non-parametric, then you know that it is either going to be Friedman or Kruskal-Wallis. But the question is it dependent or independent? Once you know that it is independent, boom, you know it's Kruskal-Wallis. So you just come to R and start typing Kruskal. See, the moment I start typing, it starts showing here. It starts showing, R detect that you want to calculate that. It will give you the dots, everything. And you can even use this help here. See, it is saying that press F1 for extra help. Okay. So it will give you an example for you to actually do it. Okay. But I have given you all the examples already. I've run them already. So let's say that I'm giving you a different data set. You will not change the Kruskal.test. The only thing you are going to change is the gene, because you would have named your data differently. Maybe you would have said Eric. And then the variable, the numerical variable in question that you are dealing with, which will come from the question. And then the categorical variable you are comparing across, which will also come from the questions. Once you know that, you just type them in, and then it will give you the beautiful result, which you just check the p-value here, which shows that there's a significant difference.
Okay. So the dollar sign must always come before the variable.
Exactly.
Letter.
Exactly.
Okay.
Now check it. Sometimes, if you check my own, I tried it twice, it didn't work, and I got to realize I need to bring the dollar sign in front. So sometimes you will not be able to bring the gen dollar. Please note, you don't just bring the dollar, you bring the data name first before the dollar. If you leave it like this, okay, sometimes it doesn't work. See what I have here. Sometimes it works, like this one just worked, but sometimes it doesn't work. So you have to bring the data name dollar before you run it.
Okay. Okay.
It's not just the dollar I am bringing, but it's a data name dollar.
Okay.
Your next question.
No,
Only you can be asking these questions. So only you. Somebody is watching, the person say, hey, maybe a chat. Ladies and gentlemen, that brings us to the end of the entire caboodle. You see, example is more efficacious than precept. My advice, go home, go through all that I went through first. Familiarize yourself with it with your group. Okay. And then make sure that you have understood at least the ones I have done here for you. So that when you get your data set, which you will have as an assignment, then you'll be able to know all of it that you can run yourself. Please get to know it now, because time is not much on your side. If there's any question, please ask now. Other than that, we are about to wrap up. Next time I meet you, we will start a new topic, which is known as descriptive statistics, correlation and regression. Correlation and regression. I will send you the entire slides, and you will type the data codes, the R codes in blue. You type all of them in your R command window before we meet. And then if there is anything that starts with library something, or anything that starts with require something, it is a package. So you have to ensure that you will install it before you come here. That way, all you do is that you run your commands and you ask questions. Most of you, the challenge you may be having is because you didn't type your commands. And so whilst I'm running them faster, you are lost. But if you had your commands, you'll be going along with me in that regard. All right. If there is no question, I wish you all the very best, and I'll see you next week. Have a wonderful evening, and bye-bye.
Bye, sir.
Bye.